Welcome, welcome, welcome. All right. Uh, Great to see folks showing up for class on the quarterdeck. My name is Dr. Jeffrey Schell. I'm an oceanography professor and chief scientist with Sea Education Association. And yeah, thanks for joining me this afternoon. Thanks for joining SEA this afternoon. Yeah, looks like we have most folks here. I'm going to stop sharing the screen for a moment just to say hello to everybody. And yeah, just saying hi. Thanks again. Lovely day here on Cape Cod, and really appreciate you coming to listen and to learn about Sargassum. Of course, any day is a great day to talk about Sargassum. And if you don't share that sentiment with me today, hopefully by the end of my presentation, you'll feel the same. All right, I'm gonna close this earlier presentation. And let me start sharing my screen again and open up this other one here. All right, today I'm going to take you on a journey. I'm going to tell you a story. A journey to the Sargasso Sea, story about Sargassum. And I'll spend a lot of time talking about the research that we do at Sea Education Association in understanding about this floating ecosystem, the only floating ecosystem on the planet. We will spend a fair bit of time talking about where the Sargasso Sea is, where you find Sargassum. And though that might seem to be an obvious question, it's been asked for centuries, and we still don't quite have all of the answers. So we'll spend a fair bit of time talking about that. And for those of you that are unfamiliar with Sargassum, don't worry, very early on, we're going to talk about what Sargassum is to begin with. But to start, I actually want to take you to the front lines and read you some headlines that came out in the summer of 2011 and again in the summer of 2012 down in the Caribbean. Things were changing. And as you can see from the headlines from Sierra Leone, changes in the air, seaweed everywhere. The Fisheries Division responds to Sargassum invasion on the island of Antigua down in the Caribbean. Where's the beach? Well, it's under the seaweed. The New York Times was even beginning to pay attention to things that were changing in the Caribbean. There were massive amounts of this algae drifting up onto the beaches, the windward beaches of Caribbean islands, in amounts that they had never seen before. In fact, some of the earliest headlines didn't even refer to this as algae, as Sargassum. As you can see, right, they were just referring to it as seaweed. Soon people figured out that it was Sargassum, and they were beginning to ask the questions, of course, of where is this Sargassum coming from? And eventually we got to questions of what to do about it. There was so much Sargassum that it was leading to millions of dollars of lost revenue due to tourism. This was impacting fisheries, as you can see in that lower panel. Fishing nets were being clogged. Small boat fishermen were having difficulty even leaving the harbor. And a great amount of money was spent removing Sargassum from beaches. The island of Barbados declared a national emergency, as did many other islands in the Caribbean. These headlines continued. It was a quiet year in 2013, but in the summer of 2014 and again 2015, Sargassum returned to the beaches of the Caribbean, and in fact all the way to Mexico, in the Gulf states of the United States. And we were beginning to learn that this was not only happening in the Caribbean, but these Sargassum inundation events were also occurring on the eastern side of the Atlantic basin, along the coast of Africa. So this was happening across the entire Atlantic basin. The other headline here, Sargassum Sea with the greatest single threat to Caribbean tourism. So this was becoming a problem that seemed to be becoming the new normal. Sargassum inundation events, where these beaches were just being buried under piles and piles of Sargassum. The Great Atlantic Sargassum Belt. And what we're seeing here again is another picture of folks in, I believe this is Mexico or Belize. Again, spending tremendous amount of time and effort and money to clear the beaches. what we're seeing in that upper right-hand panel are over the course of years from July 2011 to July 2018, we're seeing the amounts of sargassum picked up by satellite. So satellites were now being employed to try to keep track of where this sargassum was. And they had sort of tuned their sensors so they could keep track of sargassum. And we're seeing that in 2018, the largest amount of sargassum ever recorded was observed by these satellites spanning in this sort of belt all the way from the African coast all the way through the Caribbean into the Gulf of Mexico. And then we can see the amount of mean coverage, how much sargassum was covering the ocean surface. And we can see the progression, how these reoccurring inundation events began in 2011 on that bottom graph, increased in 2014-15, increased again 2017-2018. So the early questions, right, in 2011, 2012, when these things were first occurring, some of the questions that were coming out of the Caribbean, at least where we were spending our time with SCA work, is what is it in the first place? In living memory, the folks in the Caribbean weren't used to seeing it. They weren't calling it by sargassum right away. They were just referring to it as an algae or a seaweed. Of course, then the next question was, where is it coming from? And has this happened before, and why is it happening in the first place was a common question you would find in the news headlines. And of course, what can we do about it? Those were some of the early questions. And then as SCA started looking into it and other researchers started looking into the question, we soon discovered that there were questions that we weren't asking that were really important. So we're going to get to some of those questions in the moments and when we discovered what is truly going on here in today's talk. So we'll get through some of those first questions we had out there. What is sargassum to begin with? What you're looking at here is, well, oh my gosh, now I'm starting to get emotional. This is just a beautiful clump of Sargassum fluitans, morphotype 3. That will make sense here later on in a couple more slides as I introduce you to different types of sargassum. But this is a free-floating clump of algae. It's never been attached to the seafloor. It's about the size of a soccer ball. You might be able to see that little shadow underneath. That's a small little fish. In this little clump of algae, and that's how you refer to them, are clumps of algae. This clump of algae is never attached to the seafloor, just drifting around the North Atlantic Ocean. And there is an incredible community of organisms that are found living attached to the sargassum, as shown in these slides here. We see an anemone, that white encrusting lattice type of material that you see in that upper left panel there. That's a colonial bryozoan. We see a colonial hydroid there in that middle panel. And then we're seeing barnacles that grow on sargassum. So there's a whole community of organisms that attach to the sargassum itself, use it as a habitat. And then there's another group of organisms sort of higher up in the food web that are swimming around, in many cases crawling around this habitat, feeding on the hydroids, feeding on the bryozoans. And you can see that they are uniquely camouflaged. Many of these species are endemic to this floating, drifting ecosystem. That bottom panel there, right, we've got shrimps, we've got crabs, we've got fish. That bottom panel there looks just like a blob, right? That's an endemic nudibranch found only on this drifting habitat. And then there's a whole group of organisms that are often associated with. They're migratory, they come and they go, but they do find themselves around sargassum, whether clumps or large accumulations of sargassum when it all kind of groups together. So mahi-mahi are known to aggregate around sargassum. The eel larvae, leptocephali, are also known to show up in higher numbers when you have sargassum around during their daily vertical migration. A number of species of seabirds have been identified to forage and feed on the crabs and the shrimp that are found there. And juvenile sea turtles are known to spend their time in sargassum mats, either hiding from predators or perhaps foraging for food as well. So to answer that question, what is sargassum? I often refer to it as a drifting oasis in the sea. Sylvia Earle, and not that I'm going to correct her in any way, but she'll often refer to it as a floating reef or a golden rainforest in the sea. That where you typically find sargassum are in really remote areas in the open ocean where there aren't a lot of nutrients. So really it's an area that is often referred to as an oceanic or biological desert, that there's not a lot of life there. But when you come across a clump or a mat of sargassum all together, then all of a sudden you have an explosion of biodiversity. Because of this biodiversity, Sylvia Earle and her Mission Blue initiative has identified the Sargasso Sea and the Sargassum habitat as one of the first hope spots because of its special abundance and diversity, unusual representative species and habitats. Sargassum is a habitat, but it also has that special diversity of endemic species, and many of them are rare. So one of the first hope spots identified by Mission Blue. So when people think of sargassum, at least before these inundation events began occurring, they thought of it as a unique habitat that needed to be protected. In fact, an alliance of a number of oceanic nations bordering the Atlantic Ocean agreed to begin outlining protections of the high sea environment, how to protect this unique ecosystem that is floating around the North Atlantic Ocean. And in the United States specifically, the South Atlantic Fishery Management Council designated sargassum, drifting sargassum habitat, as essential fish habitat because of the species of organisms that seek this habitat as a refuge or as a foraging location. So sargassum, something that's worth protecting. But where? Where do you find it, right? This is a drifting oasis in the sea. It's moving around. So the natural place, of course, to protect sargassum would be to protect the Sargasso Sea, the area of the North Atlantic Ocean that is named because of the seaweed that is found there. But we're going to find out that defining the boundary of the Sargasso Sea, if you're defining about where you find sargassum, actually isn't so easy as perhaps this figure depicts. But what's shown here in red is the region of the North Atlantic Ocean that the Sargasso Sea Alliance, and now it's known as the Sargasso Sea Commission, is in continued efforts to try to protect this high seas environment because of the abundance of floating sargassum that you do find here. So that leads to the next question. If we want to protect this habitat, where is it? So where is the sargassum coming from? We're looking at a figure here, an 1873 map by a French scientist, and the green dots are just showing where, at the time, ships had observed where sargassum was found. You can see in that sort of central gyre of the North Atlantic, bounded by the ocean currents that create the North Atlantic gyre. But I do want you to pay attention to a little subtlety. There's a little bit of sort of eastward, leaning of the amount of sargassum that you find in the 1870s, 1860s, 1870s. A little bit more to the eastern side of that gyre is where most of the sargassum is found. And that leads me to how does one go about answering this question? Where do you find sargassum? So we're going to start off by looking at historical observations. SEA is the largest data set of in situ collections. So we'll talk a lot about what SEA has learned about where you can find sargassum and how that's changing. And then there are folks that are modeling the movement of winds and currents and how that then redistributes sargassum within the North Atlantic. And then, of course, remote sensing, which I have mentioned earlier and will mention again. So if we take a look at a close read of Columbus's logbooks, his first voyage on 16th of September at approximately this location. This is the first time he records observing sargassum, though he doesn't call it sargassum, he refers to it as a weed. Finds it in the ocean, and 11 times of the next 24, he talks about seeing sargassum. So this is really our first indication of where sargassum is distributed, at least back in the 15th century. Ben Franklin, when he was charting the Gulf Stream, was able to get some of his measurements based upon the not only the temperature of the water, but he would note the presence of what was referred to as gulfweed at the time. He was trying to chart the Gulf Stream coming out of the Gulf of Mexico, and he was using the sargassum that he was finding associated with this warm current as a way to map the position of the Gulf Stream. So there's certainly a relationship with the Gulf Stream and sargassum. Favorite naturalist of mine, Alexander von Humboldt, when he crossed the Atlantic, as well as keeping track of other published work in his time period, in 1804, delineated the boundaries of what he was referring to as the Fucus Bank. He thought the presence of this drifting algae was actually an indication of shallow waters in those areas, which we know is not the case at this point in time. But again, in the 1800s now, we have another window into the distribution of sargassum. And note here that there's a whole section of sargassum off to the eastern side of the North Atlantic. Matthew Fontaine Maury, a few decades later, in his compilation of ship's logbooks and the early creation of pilot charts, gave him the nickname as the father of oceanography. He maps the Sargasso Sea. And again, you can see these sort of bimodal distributions, but there's, again, sort of concentration off to the eastern side of the North Atlantic Ocean. Let's see why that's important here in a few slides. And then this backdrop that I've been using, a German scientist, Krumel, he identified what he referred to as isophycoids in 1891. And what I've highlighted there is the region where at least 10% or more observations from ships noted the presence of sargassum. But now we're starting to see here in the later 1800s, the concentration of sargassum moving more and more to the western side of the North Atlantic basin. This is a map here, a review paper by Dooley in 1972, where he shows Krummel's boundaries, the dashed line. Wing in 1923 is the solid line. That hatched circle in the middle near Bermuda is where Conover and Seaberth in 1964 studying sargassum said this is where the center of the Sargasso Sea is. So in this review paper, we're seeing again this sort of shift now in more contemporary times to the presence of sargassum more on the western side of the North Atlantic basin. That's going to be an important distinction later on. So pay attention to that eastern shift to the western side of the North Atlantic of sargassum. Now that's looking at historical data, but right in 2011, some researchers out of Canada, Gower and King, in 2011, were using a different technique. Rather than looking at historical records, they were using modern technology, remote sensing from satellites. And they had tuned their sensors just right. Were looking in the right place at the right time, and they believed that they were tracking sargassum remotely. And they made what at the time was considered a real novel hypothesis. The results of their study suggested a seasonal pattern in which sargassum originates in the northwest Gulf of Mexico in the spring of each year and is then advected into the Atlantic. So that the sargassum that you find in the Sargasso Sea actually doesn't come from there. It's actually coming from the Gulf of Mexico. So that went against most historical convention and understanding. And what you're seeing in here is basically a graphic of their model, their hypothesis, that sargassum begins in the spring in the Gulf of Mexico, following the flow of currents, those black arrows, the Gulf Stream, leads you out into the North Atlantic. But what they're also suggesting is that because of this annual growth in cycle of sargassum is that they make a prediction that if you look in the Gulf of Mexico, you'll look at sargassum that is young and growing vigorously in the spring. You can notice that by the color of the blades and the floats. And that as that sargassum progresses through the spring and the fall, through summer, and then eventually to winter, that sargassum should age, discolor, and then sink away. Because we're not just continuing to fill the Sargasso Sea with sargassum. their model suggests that there's influx of new sargassum out of the Gulf of Mexico into the Sargasso Sea, ages and dies, and then that cycle repeats. So this went against hundreds of years of history of sargassum distribution, but it also went against just the common knowledge that folks that were working for SCA at the time had about what they knew about sargassum for all of the times that we had sailed through this area. So again, right, this is ahead of all of those headlines. Before those new headlines, before the inundation events occurred in the Caribbean, that paper came out by Gower and King, and we had a focus for one of our sea semesters is going to test that hypothesis. It was a perfect cruise track for it. We were starting in Key West. We're going to go to Bermuda, finish in St. Croix. We're going to sail right through the Sargasso Sea at the right time of year to test the Gower and King hypothesis. So indeed, as we were leaving Key West, we were finding a modest amount of sargassum. And it was a mixture of young sargassum and old sargassum here in the beginning. For folks that are unfamiliar with the work that we do at SCA, this is a Newston net. And we tow that Newston net 2 times every day while we're at sea. So hopefully this video is coming through. But the Newston net is 1 meter wide, 1/2 meter tall, 335 micron mesh. So we're going to get all the fine stuff, but we're also going to be collecting sargassum along the way. So now we're going to take a little closer look. Yeah, we have been towing that net the same way for decades. We're going to get a nice close view here pretty soon. Here's a view of the Newston net in the water. This was taken just a couple years ago. And what you're seeing as sargassum comes by, and you can see it's a nice long line. Those are called windrows of sargassum. And the way that we sail the SCA ships when we're towing our net is that we've got the wind on the beam and these windrows which align themselves parallel to the direction of the wind. And we just come across these windrows perpendicularly, and the Newston net grabs just a little bit of them. We've been towing the Newston net now for close to 50 years, usually 2 times a day, at the speed of 2 knots for a half an hour. So it's an incredible data set, allowing us to understand the distribution of sargassum over time. So this is what we were deploying during the cruise C240. And when that Newston net comes aboard, we rinse and measure and weigh all of that sargassum. We pick out all the cool organisms, get the zooplankton and the halobaides and other larger organisms out of the way. And you can see that we've got sargassum off to the side in our bucket. We count and sort and identify all the different organisms that you find there. And then for this particular cruise, we were really interested in determining the age of the sargassum. And you can do that by looking at the color of the blades and the floats. And it's just like, you know, I can probably look at my fern over here and I can see that there are some fronds of my fern that are beginning to age and, you know, decline. And then there are new fronds growing. And that happens on sargassum as well. But if that sargassum is really getting old, more of it's going to be brown. And if it's young and vigorously growing, it's going to be more of a yellowish, lightish green color. So I spend time describing this because we spend a lot of time at SCA paying really close attention to sargassum. And that's going to be important later on. So we're leaving Key West, we're sailing here. We saw some sargassum, but as we make our way to Bermuda, we're seeing even more and more sargassum. And again, as we're looking closely, we're seeing a mix of young and old sargassum, all kind of mixed together. Not really following that hypothesis. At this point in time, we should be getting all old stuff, but that's not the case. As we're making our way south from Bermuda, heading toward the Caribbean, we're starting to see even more sargassum than we saw earlier on. At this point in time, we should be, according to the Gower and King hypothesis, kind of running out of sargassum. It should all be getting older in coloration. And instead, we're just seeing massive amounts of sargassum on this trip. And now we're getting to the point here where we're reaching that historic boundary. All of those earlier maps and figures that I've showed you, by the time we cross 20 degrees north latitude, we should run out of sargassum. Shouldn't be around, shouldn't be in the Caribbean at all. And instead, what we observed, right, this is 2011, we were right out there in the midst of the beginning of these inundation events. We weren't expecting it, of course, right? This is something that was happening unexpected. We were out there testing a completely different hypothesis, and we found ourselves right in the middle of the first inundation event that was going on in the Caribbean. And we discovered, right, again, more sargassum than had ever been seen below that historic boundary. We were finding it in the Caribbean where for hundreds of years, you just really hadn't seen it before. So SCA was uniquely positioned at the start of these inundation events that we had been collecting sargassum for decades at this point in time to be able to answer some of those early questions. Had this ever happened before? Is it going to happen again? Where is it coming from? So SCA was really uniquely positioned to not only test the Gower and King hypothesis, which was our intention at the start of this cruise, but to now, as we returned home and realized that this strange event was going on, that if we were to look back in SCA's archive data, we could answer some of these questions. And even though we were trying to answer the question of like, has this happened before? Where is the sargassum coming from? Again, as we dove into the SCA archive, some other unique patterns revealed themselves that led to some really important questions. And at this point, of course, in time to recognize not only all of the SCA alums over the years that have helped collect this data, but in particular, Dr. Amy Sweeted, Dr. Deb Goodwin, Sky Murray, in the early phases of our analysis of SCA archive data, they were a big part of this team. So at the time, we went back into the archive to 1992 to 2013 to start addressing some of these initial questions. We had 6,610 tows, and we divided them up into important biological regions, geographic zones, and we started analyzing our data. Of those 6,000 tows, nearly 3,000 of them had sargassum across a range of different amounts of sargassum in those tows. And we identified this as kind of an important boundary. That clump there signifies 0.01 grams of sargassum per meter squared from a Newstein net. That means that we got one clump of sargassum in that net. But anyone who's watched the Newstein net go by, oh my gosh, how many clumps of sargassum do you miss that just didn't quite get into the net? So this we identified as sort of a significant ecological level of sargassum in the environment. So this was going to be sort of our amount of sargassum that defines some important boundaries. So if we take a look at that distribution of sargassum, we look at it across our different regions, and there's our cutoff line. And we see that the Western Caribbean just makes it into that ecological threshold, as well as the Sargasso Sea, the Florida Straits, and Gulf Stream. And if we look even more closely at how many tows in that area, this is the percentage of tows. So nearly half of the time that we towed the Newstein net in the Western Caribbean, we were getting sargassum. Maybe it was just a little bit, but it was there. So because of that, we identified this to be the boundary of the Sargasso Sea, at least defined by where you find sargassum. So to include the Western Caribbean as well as the Gulf of Mexico. So a little bit beyond the traditional boundaries of where you find the Sargasso Sea. Now back to that original question during this cruise. Are Gower and King just crazy that remote sensing that sargassum originates in the Gulf of Mexico or not? So to test that, right, when we look at the archive of data that SCA has collected over the years, when Gower and King say we should find sargassum up in the North Sargasso Sea, North Atlantic, that's indeed where our archive says we found sargassum as well. However, in the spring where their satellite data was not picking up sargassum, you can see the regions where they found it in those blue circles. That's where they could see sargassum in their remote sensing data. But we saw it in high concentrations in areas well beyond that. So clearly, remote sensing is a powerful tool. It does pick up some sargassum, but it doesn't pick up all of it. So a useful tool in some regards, recognizing that remote sensing in combination with some ground truth in situ nustantos need to really be used in tandem to help address this question. But more importantly, what we learned as we dove into the archive of SCA is that not all sargassum is the same. This is something we knew and we paid attention to and we recorded in our data sheets anytime we collected sargassum, is that there are two common species of sargassum drifting around out there. Sargassum natans 1, Sargassum fluitans. And the big telltale sign that you have Sargassum natans are the little spines sticking off of the end of the floats. You don't see that on Sargassum fluitans. If you pay really close attention and look at what you would call the stem or the stipe of this algae, you see tiny little thorns growing along the stem. So SCA is, right, for decades been separating out those different species of sargassum, and they show somewhat similar patterns. Here in the North Atlantic, we see both natans and fluitans showing up. But in the spring, we see that Sargassum fluitans is a little bit more broadly or widely distributed, whereas natans really seems to stay confined within the Sargasso Sea. So if we sort of merge those two data sets together and subtract one from the other, we can see that there's a higher concentration of Sargassum natans in the south, Sargasso Sea, and a wider distribution of Sargassum fluitans. So these were patterns we hadn't necessarily identified on the day-to-day towing of a Newstown tow or the pattern that you see in a single cruise. You really could only understand these patterns by looking at the whole archive over a span of time. And what we can see here is that Gower and King idea that sargassum starts in the Gulf of Mexico and moves its way into the Sargasso Sea. We think that's true, at least according to our data set, but that's only true for Sargassum fluitans. And Sargassum fluitans, what it does in the eastern part of the North Atlantic, we don't know. SCA doesn't sail over there, so we don't have any data on the eastern side of the Sargasso Sea. But then in the data set, there's evidence that this Sargassum fluitans follows the ocean currents and makes its way back into the Caribbean Sea and the South Sargasso Sea. And something perhaps changed in 2011 and 12 to lead to these large amounts of sargassum showing up at the Caribbean. At least that's our hypothesis. And then for Sargassum natans, the SCA archive suggests that it's kind of just hanging out around there in the Sargasso Sea. So that really is sort of a home region for that type of sargassum. So that was our sort of conclusions based upon our deep dive into the SCA archive and addressing that Gower and King hypothesis, is that we're now finding sargassum well beyond historic boundaries of the Sargasso Sea to include the Western Caribbean and Gulf of Mexico. The patterns of Sargassum natans and fluitans show seasonality that Gower and King predicted, but not necessarily the distribution that they suggested. Fluitans and natans have overlapping geographies, but yet there's some distinction between the two species and how they're distributed. And we still haven't answered that question of where is that sargassum coming from during those events in 2011 and 12. But we had a good hypothesis that was going to lead into our next cruise track. So around this same time, SCA was beginning to change their cruise tracks. We did a transatlantic for a number of years over to the Mediterranean. And I was lucky enough to be a part of the voyage that was going to bring the Kramer back to the Caribbean. Cruise C256 in the fall of 2014, leaving the Canary Islands, finishing in St. Croix. And based on the historic data, we had a hypothesis. That small circle, if you remember, that's where Columbus first cited sargassum in his journals. That next, the overlay is Alexander von Humboldt's position of Sargassum based on his historical observations in ship logbooks. And there's Matthew Fontaine Maury's distribution. Remember that eastern focus or concentration of Sargassum in the earlier years. Our thought here at SEA was that some long scale change in North Atlantic circulation was going on, and we were just getting a redistribution of Sargassum into the eastern part of the gyre, and that was just going to flood its way into the Caribbean. So when we were beginning this cruise in the Canary Islands, we thought we were going to just follow the Sargassum right into the Caribbean and be the ones to identify where this Sargassum is coming from. But there was a competing hypothesis out there. There were modelers who were starting from the beaches in the Caribbean and then backtracking ocean currents and backtracking the wind patterns in the days and weeks before those inundation events and saying, you know what, this Sargassum, if it's being moved around by winds and currents, it seems to be coming from the Equatorial Atlantic Ocean, a place where Sargassum has never been, you know, described, charted, mapped as a source for Sargassum before. But the model suggested that that could be a source region. So we had yet another paper, another group of scientists offering a hypothesis, and SEA wanted to go out there and test it. And we certainly had expectations that we were going to be seeing Sargassum up here in the eastern Sargasso Sea, more in line with some of these historical studies. As we left the Canary Islands, you could find myself and the students and the crew out there looking for Sargassum. We thought for sure as we crossed into Maury's boundary, we would see it, but we didn't. Then we came upon Columbus's historical region of where he first sighted Sargassum, and we didn't see it. And thought for sure, well, Alexander von Humboldt must have it correct. So as we crossed into his boundary, we thought for sure we'd see Sargassum, and we didn't. So at this point in time, we were running out of time, and we had to make our way to the Caribbean. So we had to sort of curtail this search for the lost Sargasso Sea and make our way further to the south to catch the trade winds. And on a momentous day, the 1st of December, 2014, started like your typical day on the Core with Kramer. We're getting ready for our science station. We're bringing in the sheet on the mainsail, hove to for science. We're putting over our equipment. The Secchi disc followed. We put the CTD in. We're getting the ship underway for a new stand tow, and then we hear from aloft. Oh my goodness. Yes, you guessed it. We saw Sargassum. After 2 weeks, we finally see our first clump of Sargassum, but certainly not where we predicted it would be. So our hypothesis of this eastern Sargasso Sea did not play itself out. Instead, what we found is that then every day following the 1st of December, we found Sargassum in our Newstown nets. And not just any old amount of Sargassum. Where we had broken records, you know, the prior years, we are breaking records again. So we'll just take a quick little look here at some of the Sargassum that we were seeing.
All right, guys. Sweet. Nice.
So as we're coming up on this windrow, remember what I described to you earlier, that oasis in the sea that we described before. All of the fish and organisms. So we're seeing a lot of Sargassum. But when I finally uploaded this footage and had a chance to look at it, I was expecting to see just a throng of fish underneath this windrow of Sargassum. For me, what jumped out was the lack of that diversity. Lots of Sargassum, but not a lot of organisms. Even though the amount of Sargassum, this is the most Sargassum that I had ever seen before after sailing with SCA for decades, and yet it didn't seem to be as full of life as I was expecting to see. Now there's a few fish that we're seeing here, and you can tell that they certainly get spooked by the small boat. But I got a fair bit of footage of this windrow, and I did not see the amount of fish that I expected to see. So I focus on that because that will be important here as we move on. So as I said, the most sargassum that had ever been recorded up to this point in SCA's time, we came up with a new scientific measurement unit. It's called the GABO, named after one of our assistant scientists. So we were measuring in how many gabos of sargassum were we getting in our net tow. And we really had to start sort of changing our protocols and not leave the net in for a full half an hour. We just couldn't keep up with the amount of processing. But more importantly, just as before, we weren't looking for this, but we couldn't help noticing that the sargassum we were collecting looked different. And as I said before, right, SCA has spent a lot of time looking closely at sargassum. And so when I tell you from the ship, looking at it in the water, it just floated funny. It just didn't act the same to me as any sargassum that I had collected before. And as we dove into the historic literature, looked at different types of sargassum side by side, we could recognize some differences. And then in 2015, me and my colleagues published this paper on the identification of what had previously been a rare form of sargassum. It was a type of Sargassum natans, morphological type 8. Like Sargassum natans 1, there are no thorns present on the stem or the stipe. Rarely does this particular form have a spine sticking off of the float, but different than natans 1, Sargassum natans 8 just has these massive blades. And the floats themselves are even just a little bit bigger. And Sargassum fluitans is just right there kind of in between. And again, any Sargassum fluitans has thorns on its stem. So not only were we seeing the most sargassum that we had ever observed before, but we were seeing a different type of sargassum than we had ever collected. So, as I mentioned, it just floated funny. It looked different. So that's why I'm going to show you a video here of different types of sargassum that you find, but seeing them in their natural environment. So perhaps you can sort of appreciate this feeling I had the first time I saw this sargassum on cruise C256. So for me, who's been studying sargassum for decades, this is just a dream come true to be floating around in just a sea of sargassum. I mean, this is just wonderful. Wow, that color of the water. Oh my gosh, it takes me away. But yeah, we're going to zoom in here a little bit shortly and take a closer look at these different forms of sargassum. There we go. So this is Sargassum natans 8. What had been described historically, but is in the historic literature was referred to as a very rare form of sargassum, and really were just lost to history. Nobody paid attention to this type of sargassum before, but now we are finding this form in great abundance. And what really stands out to me is that it's kind of two-dimensional. You can see, we're on one side of the clump of sargassum, you can see right through it to the other side, that the branching is so wide and open. And for us, it didn't really seem like a great habitat if you're a small shrimp or a crab trying to hide from a predatory fish. But there isn't really a great place to hide in Sargassum natans 8. But now we take a look at Sargassum fluitans 3. This is a type of Sargassum that SCA is familiar with collecting for decades. And you can see the compactness of it, the sort of three-dimensional structure to it, shorter branching, shorter blades. You can see, you can imagine lots of little places for shrimps and crabs and nudibranchs and snails and things like that to hide from predators. Fortunately, I haven't gotten a good sample or a good video of Natans 1 floating and drifting around, but I've got some still photos. And there's Natans 1. Again, this nice, compact, tight branching structure in comparison to Natans 8. More two-dimensional, very open branching. And then Fluitans 3, slightly looser clump, but still three-dimensional in shape. So different Sargassum forms. And when we came back from that cruise, we realized that, this is something that we need to tell people about. So we identified that there were these 3 different forms of Sargassum, and that it appeared, at least at this time point in 2014, that Sargassum natans 8 was the form of Sargassum that was responsible for these inundation events. And we're seeing that in these pie charts here. There's darker color representing Sargassum natans 8. It was much higher abundance in the tropical Atlantic, Eastern Caribbean, and the Antilles currents. And then the more traditional forms of Sargassum, natans 1, fluitans 3, more abundant in the traditional regions of the Sargasso Sea. What's important in this panel here that just showed up is the change in the amount of Sargassum found over time in 2 different regions. Here we're looking at the Western tropical Atlantic, and before 2011, you didn't find Sargassum down here. In 2011, that was when we first started seeing it, cruise C240. And then on subsequent cruises, massive amounts of Sargassum. This is those inundation events of 2014 and 15 that increased. But in the Sargasso Sea, over that same time period, we do not see that the amount of Sargassum has increased or decreased across that same time frame. So that suggested to us that the Sargasso Sea was not the source of the Sargassum coming into the Caribbean, that there must be a new source, that new source indeed was the tropical Atlantic. So in this case, these alternative hypotheses of where the Sargassum is coming from, all of our data supports that there is an equatorial source of Sargassum. So our initial hypothesis of an eastern Sargasso Sea, right, that wasn't correct. And we weren't even really asking the most important or relevant question. The most important question is this a different type of Sargassum? And that's the biggest contribution that SCA is making to the story now. Just a subtlety to point out here, we repeated that cruise track 2 more times. So in 2 more years, we did that same cruise track from the Canary Islands to the Caribbean. In all 3 of those years, in the early part of the cruise track, we still didn't find any Sargassum. I point that out because that would have been the avenue. If there is a connection between the Sargasso Sea and the Equatorial Atlantic, it's going to be in this region right here. And at least for 3 years running, we didn't find any Sargassum in this zone. So it really suggests that this is a true source region of Sargassum, not just a displacement from the Sargasso Sea to this region. So recognizing that we were identifying a previously rare form of Sargassum, that really then led to a whole new slew of questions for us to consider. So are there more Sargassum forms out there? Are these Sargassum forms genetically different? Is the ecology of these different types of Sargassum different? So we focused on some of the organisms that attach to the Sargassum, the mobile fauna, and then a real deep dive into the shrimp that associate with Sargassum. So we'll see a little bit about all of this in the slides to come. And because of these inundation events that they continue to occur, that the ecologies may be different for some forms of Sargassum, one question is, do we still want to conserve this Sargassum habitat, or do we want to consider it an invasive species? And you'll see where I lean on that here in a little bit. And is there more than one Sargasso Sea? That is a question that is on our minds. So, Corey Wren, an alum from C257, he presented at the Gulf and Caribbean Fisheries Institute annual conference. I believe it was in the Cayman Islands. And indeed, right, in the subsequent years, we have found other rare forms of sargassum. And Corey was the first to do some of the initial drawings and identification of these rare forms. So now we're keeping track of at least 4 different sargassum forms on our Nustanto data sheets, thanks to Corey's work. And we indeed have been looking at the genetics of sargassum, and that was in the early days. Nick Dragone, who became an assistant scientist for us, but on cruise C256, where we came across this form of sargassum for the first time, he was on board as a visiting scientist and did some of the initial sargassum genetic work, along with Linda Amaral Zettler and Eric Zettler, familiar names to folks, identifying that indeed there is a genetic difference. And in these early stages, we were only able to figure out that natans was different from fluotans. This was some of the earliest work. But continued work with pioneering work by Amy Sweda and her work with the Marine Biodiversity and Conservation Program C semester that we do. Amy really focused on sargassum genetics and looking at the sargassum community. So she and her students continued to work on sargassum genetics and have done a deep dive, and have just recently presented at Ocean Sciences in 2020 a more thorough genetic delineation of the different sargassum forms. You can see that in the top right panel, especially if you move your little video screen over. You can see that we now understand and have found the correct genes to differentiate between the different sargassum forms more fully. And most recently, Amy Sweda and her work at Eckerd College has just helped a student from Eckerd, Sky Dibner, to also present at Ocean Science meeting to complete her senior thesis on this genetic work. And I just have to say a shout out and thanks to Carrie Whitaker and her MBC students and the TAs for the MBC program over the years have continued to help collect these sargassum samples and help us identify that there is a true genetic difference between these morphological forms. And that was something that in the early days, many people were questioning. All right. Maddie Taylor, Lindsay Martin, Grayson Houston, and of course, many other C semester students over the years. But at least those 3 students have helped us put together publications and presentations, and some have even gotten their master's theses looking at the mobile fauna community. What we're seeing there is just a clip of a poster presented by Lindsay Martin at Ocean Sciences here in 2020, confirming what I was sort of alluding to in that video of the sargassum windrow, that there are indeed different ecologies going on with these different forms of sargassum. Differences in abundance of individuals, the diversity that you find in the community structure that you find around these different forms of sargassum. So not only are they genetically different, but then it sort of makes sense that they're going to be different ecologically as well. Lindsay's done a deep dive along with some of her co-authors into looking at sargassum shrimp. We were able to identify that a certain species of sargassum shrimp seems to have an infestation of these isopod parasites, and that the distribution of that infestation changes geographically. So that was a nice short little publication. So we're doing a deep dive into the ecology of the sargassum community. And really in an important paper, this is in collaboration with Woods Hole Oceanographic Institute, Annette Gomajaran, and many other co-authors over the years. Work that Amy Sweda did with MBC students over the years is looking at the genetics of the hydroid community that attaches to sargassum. So this is an organism that drifts around with the sargassum. And indeed, we're finding that there are genetic differences amongst hydroids on the different forms of sargassum, suggesting that there is, again, this isolation. If you're going to get genetic differentiation, you must be isolated in time over or some span of time for that speciation to occur or begin to occur. So we have population level differences in the genetics of hydroids on different forms of Sargassum. And this lays more credence to the idea that Sargassum natans 8 is indeed coming from a different place. And this all leads again to right back into the early part of this presentation, this floating oasis, drifting oasis in the sea. Different Sargassum forms, different ecologies, but still an important ecosystem when it's out there drifting around in the ocean. When of course it washes up onto beaches, that's going to lead to economic hardship and ecological damage in those coastal areas. But the habitat itself, the unique community that you find in Sargassum, it's important, it's still worth conserving, especially now as we're seeing such changes occurring in the North Atlantic Ocean. And NBC students under the leadership and guidance of Carrie Whitaker and her collaborators, Porter Hoagland from Marine Biological Labs, have worked on combining the science to inform ocean conservation and policy. And we had a wonderful opportunity for NBC students to go and present at a UN conference talking about sustainable ocean management. And these students brought the Sargasso Sea to the UN, talking about the importance of continuing to conserve this important habitat. So SCA is right in the thick of it, and currently what we're focusing on is trying to address that question. How many Sargasso Seas are out there? And our collaborator, Deb Goodwin, right, great friend, former chief scientist at SCA, she's taking the lead on what is going to be the next important paper out there, where we define the 3 different Sargasso Seas, each of these 3 forms of Sargassum having their initial home range, but recognizing that they are being redistributed through ocean currents and winds. So this is now updating our Mustanto up to 2019 to include these inundation events, and identifying that historically these different forms of Sargassum seem to be isolated, though there is some overlap in their range. But we're now beginning in more recent years seeing an expansion of some of these forms in different regions. Fluitans 3 is beginning to spread out. Natans 1 is beginning to spread beyond its former home range. And Sargassum natans 8 continues to be spreading throughout this system. So how many Sargasso Seas? We'll be identifying that there, at least at one point in time, were 3, but now things are continuing to change. So more reason for more new Stantos, and more reasons perhaps to check in the next time we have a Sargassum webinar. All right, with that, I'm going to stop sharing my screen, and hopefully everyone stuck around and there are some questions.
Great, thanks, Jeff. That was awesome. I just want to let people know that we are recording. So as you can unmute yourself and speak up with questions, or you can type them into the chat box on the side here. But please be aware that we are recording this.
Yes, please go ahead.
I may have missed it because I had to get up for a minute, but did you mention the eels that are born there?
Only briefly did I mention them, as we have found in our data set at SCA that you find more eel larvae when you have Sargassum in a certain location. So there does seem to be some affinity for the eel larvae to use Sargassum when they come up to the surface. You know, eel larvae vertically migrate on a daily basis, and they come to the surface at night. They go deeper down in the water column during the day, but you find more eel larvae around Sargassum when it's around.
Because for me, the Sargasso Sea has always meant the place where the eels are born. Mm-hmm. And then they migrate to the rivers in the eastern United States, as far as I know. And they
absolutely right.
They go up the rivers and they spawn and and they live there. And then they make their way back to the Sargasso Sea to spawn. Is that right?
You have that absolutely right.
Is it?
Yeah, no, it's excellent. And yeah, it was only in a couple years ago. It was Amy Sweetas led the effort. She was working with the Sargasso Sea Alliance, and the
Mhm.
Sargasso Sea Alliance was trying to make the case why sargassum is worth protecting.
Yeah.
And we, brought our SCA archive to bear, took a close look at that, and found that nice association of eel larvae with sargassum. And that was one amongst many reasons that the Sargasso Sea Alliance was able to make the claim that this is an important habitat worth conserving. Yeah, thanks for bringing that up.
It is. And I learned today that the Sargasso Sea moves around. It's in different places in the Atlantic. And so I always thought they were just sort of circling around east of the Bahamas or something like that. But it's in so many places, they find their way back.
No, and it really seems to be very dynamic, and certainly in the last decade, changing the distribution considerably.
That's right. Oh, that's right. It's changing. Perhaps it used to be more sedentary.
Well, and I think a lot of that just depends upon how close, how we were paying attention. And we're certainly paying attention now.
Probably, yeah. Well, thank you. That was most interesting.
Yeah, thank you. So I'm going to take a quick look over at the chat window. Molly Boyd, I work on a sailboat in Key West, Florida, and often see patches of sargassum accumulate as far as the eye can see. Oh my goodness. Molly, get some photos and send them my way, please. Yes, right, and the best place to catch mahi. And that when we were sailing across from the Canaries to the Caribbean, I was expecting a boon of mahi, and we did catch a lot, but not necessarily associated with the sargassum. So that was a surprise, but in the Sargasso Sea and in the Caribbean, totally. We always get our best mahi when the sargassum's around. Let's see. All right, Daryl, thank you. Sue, thanks so much. This was fantastic. Yes, I remember W140. Sue, it was a great sailing with you. Yeah, thank you very much for listening in. Let's see, is there anything similar to sargassum in other oceans of the world? That's a really good question, and it depends in similar in what way. So I'm often quoted as saying it's the only floating ecosystem on the planet. And that comes with a bit of a disclaimer or a caveat. It's the only self-sustaining floating ecosystem. So the sargassum that we find in the North Atlantic Ocean is considered truly pelagic. It's never attached to the seafloor. It self-sustains by just vegetatively growing. There's no sexual reproductive organs identified for these types of sargassum. They just grow vegetatively and continue to spread out. But you find sargassum worldwide. Sargassum is a benthic algae. Most species of sargassum are attached to the sea floor. Worldwide, between the tropics and temperate zones, there's benthic sargassum you find around Cape Cod. And sometimes that benthic sargassum gets mixed up and then washes out to sea. And you can find that in the Pacific Ocean, the Indian Ocean. You can find all sorts of flotsam and jetsam, things that are floating around, but they're not self-sustaining. They only periodically get cast out to sea and are floating and drifting around. Southern California Bight, California coast, Japan and China coast, where you get large growths of algae. That benthic algae will, in storm events, get ripped up and float around, but it doesn't self-sustain. It'll eventually die away and sink away. So the only sargassum in the North Atlantic and Caribbean is the only self-sustaining floating ecosystem out there. So yeah, that's a good question. Let me sort of point out those unique differences. Let's see, I have a question. This is Anthony. I have a question. I was interested in the value of archival sources. Yeah, 19th century distribution maps. I love old maps. Might there also be valuable information related to this project in biological collections from the 19th century, from museum collections? I'd love to know more. If you have some thoughts or ideas on that, I'll type my email here in the notes section, and would love some thoughts on that. I'm aware at the Peabody Essex Museum here in Massachusetts, Albert Parr, he was the first director of the American Museum of Natural History. And oftentimes when I refer to in the historic literature, when they've described these rare forms of sargassum, it was because of work that Albert Parr did in 1939. And there were a few others that preceded him that he referenced. But when we identify natans 8 or natans 1 or fluotans 3, those designations come from Albert Parr, and his herbarium specimens are at the Peabody Essex Museum. But those are well documented in the scientific literature as well. So we have his designations and distributions of sargassum to work from. But if there are other archival sources of material that aren't published, my goodness, I'd love a lead on that. So great question, Anthony. Let's see. Yeah, Molly, get those photos, please. Karina, I have a question about the satellite imagery, how it works, detecting heat or light, and why not more accurate? Yeah, Karina, that is an excellent question. The scale and resolution of that, I can't say specifically what resolution. I know that first paper that came out in 2011 by Gower and King, they had about a 1,200 meter resolution. So that's huge, right? Massive scale. So you need huge amounts of sargassum to be registering in the first place. Now, they've certainly improved that resolution. I don't know exactly at what scale they are right now. I'm not sure who all of our, if we have maybe Deb Goodwin. I know she did some remote sensing and really paid attention to that literature over the years and might be able to answer what level of resolution we're at now. But they're not looking at heat, they're looking at certain wavelengths of light that are given off by sargassum. And they recognize that sometimes phytoplankton can also give a similar signature. They're trying to refine the proper wavelengths of light that are reflected off of sargassum because of the pigments sargassum has that not all other phytoplankton have. So they're getting better and better. The resolution is getting better. But they're not looking for heat. Yeah, they're looking for a wavelength of light signature to pick it up. But yeah, again, right, the remote sensing data, incredibly powerful, but I don't know if they'll ever get to a point that they can identify different species of sargassum. So there's always going to be a need for ground truthing and for Newstone toes. So I got to make that plug so I can keep my job. Helen, yeah, great to see you. Thanks for coming. From the Netherlands, wonderful. All right, another question, Karina. What does it sustain itself on? Right, yeah, so sargassum, all right, it's an algae, so it's photosynthetic. So it's just, it needs light, needs nutrients, needs water. It's got plenty of that out there. So, but what might be a follow-on question, or then what makes you think about it, is what's eating sargassum? You know, and sargassum has evolved to be that habitat, and the species that live on it, a little bit perhaps smarter than ourselves, right? We're kind of ruining our environment of planet Earth, but the organisms that live on sargassum don't eat it. That's their home. They know not to mess with it, so that home continues to float and drift around. Now, of course, there are some organisms like the bryozoans and hydroids that begin to weigh down the sargassum, and that sargassum drifts into an environment that's not favorable for its growth. Eventually, the organisms will overpopulate that sargassum clump, and it can sink away. And we think, right, sargassum doesn't just continue to increase, but eventually it does die away, but not because anything is eating it. It's not known that there are any organisms that eat sargassum intentionally. You do find sargassum in the stomachs of turtles and fish and seabirds, but only because they're probably eating other things and ingest sargassum sort of accidentally. Now, I've been known to eat sargassum and to get some of my students to eat sargassum. And I have a great recipe for Sargassum tea. So I'll be sharing that in an SEA newsletter one of these days. So keep an eye out for that. Let's see. Oh, yeah, you know, I've never learned how to fly a drone. So I haven't taken a picture of Sargassum with a drone. I've taken pictures from aloft. I usually more likely would rather get in the water with it rather than fly a drone above it. But I agree, you know, we need to get some more pictures at SEA of Sargassum from a drone. Femi Suida is on. She may have some pictures of Sargassum from a drone. I know Amy Suida used to work with some collaborators and work with drone footage during the marine biodiversity and conservation programs. But I'm not hearing Amy pipe up, so she might not be on. So I can look into that and add them to the future presentations. So Karina, I love it. Keep the questions coming. So when you first said it looked different, I thought the punchline would be that filled with microplastics. Yeah, you know, you do find, you know, and this is something that has intrigued me for a while. This is a good question, Karina. That's right, Karina's question about microplastics in Sargassum. In the middle of the Sargasso Sea, this is where SEA's record in the Atlantic and Pacific, in the middle of those oceanic gyres is where this plastic tends to accumulate. This plastic soup that is out there, well documented. And I've always found this intriguing and haven't come up with a good way of understanding and studying why this is different. But Sargassum moves into the Sargasso Sea, but then it moves out. And it kind of moves through that circulation pattern. That's why you see Sargassum in the Western Caribbean. That's why you see it in the Gulf of Mexico. And then it circulates through and it comes back into the Sargasso Sea, but the plastic stays there. I haven't quite figured out what is going on different with Sargassum because it does get mixed around. Some of it does stick up out of the water. I don't know if that just creates enough drag, but Sargassum seems to move through that zone, kind of accumulates in the Sargasso Sea, but there's clearly evidence that Sargassum moves out of the Sargasso Sea as well. It doesn't stay there. It moves slowly in and out over time. So at least that's my impression of it. Because you don't find Sargassum just in the Sargasso Sea, certainly not anymore. And in SEA's record, we find plenty of Sargassum coming through the Windward Passage into that Western Caribbean, and it came from the Sargasso Sea. So there's certainly an association. They co-occur, Sargassum with plastic, but they move around independently of each other. But that's an interesting question. So yes, no, okay, yeah, Karina, keep the questions coming, or if anyone else. So I'll just leave it open for a little bit longer, but otherwise, I will just say I'm going to open up my gallery view here, just to sort of see folks. But yeah, really appreciate everyone spending their time with me this afternoon, spending time with SEA. Encourage folks to continue to check out the SEA website and look for announcements for future webinars. I believe our first captain will be presenting next week. And yeah, stay tuned for future news about Sargassum.